let me introduce myself. I am Chandrali and I have around 7.5 years of experience in IT. And I have worked on big data and other tech stack, mainly on the big data side itself and cloud and AWS and Azure. Yeah, that's about me. So you can introduce yourself.
My name is Soumyaranjan Parida. I stay in Kolkata and right now I'm working at Accenture as a data engineer. Previously, I used to work at ITC as a data analyst. Right now, my tech stack includes Azure Databricks and also SQL and along with it ADF. And prior to that, when I was working as a data analyst, it included Tableau Power BI.
Okay.
Yeah.
And what programming language have you worked on?
Specifically, like I haven't worked on in any such like in-depth. I haven't worked in any programming language, but yeah, basics of Python I utilize day to day. Yeah, that's the thing.
Okay. And Spark you have worked on?
Spark I have worked on in Databricks itself.
Okay. Have you worked on any data warehouse?
No, I haven't worked on data warehouse till now.
Okay. 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 So yeah, let's start with Spark only. So you said you worked on Databricks,
Yeah,
right?
yeah.
So what is the okay, can you tell me about your project right now? Like what is the end-to-end pipeline? What are the services being used and how are you utilizing that? What are the file formats that you are receiving? Just an overview of how it is happening.
Yeah, sure. Right now I'm working for a gold mining company. So the basic project revolves around the fact that we are trying to build a data platform from them, and from that data platform, they are utilizing that data platform to build their KPI reporting system. So we receive data from them in the SQL data warehouse, okay, and Azure SQL data warehouse, and after that, from there going forward, we try to retrieve the data through Databricks. Like we do certain transformations through multiple Databricks notebooks, and after utilizing those Databricks notebook, we then going forward try to do certain transformation using the stored procedures. Okay, and after utilizing those stored procedures, we then finally put that into two end tables. One is fact. There are two fact tables in which we put the data, and the UI screen utilizes that data to show the results. So the transformations that we go do utilize in the Databricks notebooks, we store the intermediary files in Delta format. Okay, and yeah, that's the basic project.
Mm-hmm. So what is the source of data? Where are you getting the data from?
We are getting the data from a single table actually. It's
It's a
called as
database.
database, SQL
Okay.
data warehouse. In this SQL data, Azure SQL data warehouse. Yeah.
Mm-hmm. Okay. And you are getting the data into ADLS.
Uh, no, we are not. We are directly trying to get that data by doing the JDBC, like retrieving
Okay.
data through JDBC connector. Yeah.
Okay. Okay. And you are storing the data where? Same database?
Yeah, we are storing the same database. Like we have multiple regions in our project. So I'm tagged one particular region. So in that region, we have a specific database of our own, and we store the data over there. All kinds of transformations. Like we have two databases in our particular region. Okay. One database is common across all the regions, which is the source data, and one database is respectively it's for ourselves only. Okay,
Mhm.
and going forward from our database we push it to the common database again. Okay, that is, and the entire thing is orchestrated through the ADF pipeline.
Understood.
Yeah.
So, okay. So you are saying, so what is the kind of data that you are dealing with? Like history data, incremental data?
It's incremental data. History means daily to daily basis data. Like we have, like it's a single table is there. It's consist of the historical data itself and also incremental data. Like within the same table, they stored the updated data and also the old records. But
Okay.
yes, it's there's a particular time frame that is up to 2 years. So
Up
data
to
of
two.
the up to 2 years will be retrieved by years.
Okay. And also, so you are saying that it's a database that you're dealing with, right?
Right.
So that means it's an OLTP.
Right,
not analytical.
right,
So in OLTP, so in data warehouse, since we have the analytical thing, we can use SCDs and everything.
right.
So in this OLTP environment, how are you capturing the incremental data? I mean, just
So
if you can explain the logic behind the scripts that you
yeah,
use.
sure. So we try to retrieve, we have two tables in our system. One is staging table and one is staging log table. Okay.
Mm-hmm.
So in the staging table, we try to get the data for every day, the updated data for every day. Okay. Like if for 30 of the, we have 30 records, like 20 records belong to new data and 10 of the records are the updated data, we retrieve that. Okay. And that's only limited to 60 days time frame. We
Mm-hmm.
retrieved that in the staging log and for staging table, and for the staging log we have data from the initial days, like from where this from days when this project started, and also the updated data. So we have two tables in which we try to get the data. So like staging log is for the purpose of like in future if we lose any data in the, do not have any data in the staging table, or there is any data discrepancy, we try to look up on the staging log table,
Okay.
and that is done through Databricks notebooks.
Mm-hmm. And
Yeah,
you are using Spark for that?
we are utilizing Spark for that.
And you mentioned stored procedures as well. So where are
Yeah.
those written?
So after getting the data into those two tables, staging and staging log table,
Mm-hmm.
what we so first of all, those two final tables, what we do, we store them in the data lake actually. Okay, in the files, and
That is
then
an ADLS.
that is in ADLS. But we have two notebooks for pushing those data, those files to database also, like right in the right format through JDBC. Okay,
Mm-hmm.
so we do that thing, and then going forward, we have two final tables which we utilize for the KPI reporting system, which is the mine means it, fact mine KPI value and fact deposit KPI value, right? Because in a particular mine we have multiple deposits which are tagged to a single mine. So right, so it's aggregation. Granularity is at different levels. First, it is aggregated up to deposit level for KPIs which are present at deposit level, and then going forward at mine level, we tag those KPIs which are tagged to mine level only, and also those which need to be aggregated from deposit level to mine level. So that intermediate aggregation takes place in the stored procedure.
And that is written in the database itself.
Right.
Okay, got it. So, what is the frequency of data that you get daily?
We receive it daily.
Okay. And what is the volume of data that you're dealing with?
Volume of data, it's not much to be true. Like every day we receive around 500 records only, not much. Okay.
I mean, in size.
In size, it's very less actually to be true. It's 1 MB around. It's only
Okay,
1 MB. Yeah.
got it. And what is the kind of file that you are receiving? Or you're getting it from the database itself?
Right, right, right.
Okay, got it. So, what are the kind of files that you have worked on?
Um,
File formats?
File formats, I've like this is my first data engineering project actually. So
Mm-hmm.
this first time I'm working with Parquet format.
Mm-hmm.
I haven't worked on JSON format and all, but I have worked on CSV format. So these are two, CSV and Parquet are the two data formats I've worked on. File formats I've worked on.
Okay. What is predicate pushdown?
Predicate pushdown basically means to filter up the data up to the last stage. Like before any action is called, we try to filter out the relevant data so that the data read or the data shuffled reduces.
Mm-hmm. Okay,
And it's an means optimization method for Spark.
right. Can you explain that in Spark as well?
In Spark, as in, suppose we are trying to like there are three operations. One is filter, one is aggregation, and then going forward we have the suppose we are collecting it. Dot collect we are calling it. So basically, first initially we need to filter out the records which we want, and then going forward we'll aggregate on that, and then we will try to call the dot collect method. So
Mhm.
basically predicate pushdowns helps in suppose if we wouldn't have filtered out initially and then later on we had after aggregation we had filtered out, then unnecessarily more amount of data would have been scanned, and this would have caused performance issues.
Mm. Okay. So what are you work on data bricks, right? So what
Right.
are the uh, optimizations that you have used in Spark?
Optimization as in to be true right now, like through adaptive query optimizations,
Mm-hmm.
like most of the things are solved out. But in the backend, like suppose if one table is big and one table is small, whenever I try to see the execution plan through dot explain method, I check it, see that broadcast join is utilized
Mm-hmm.
instead of normal
What is
join.
broadcast join?
In broadcast join, basically the small data of the smaller table is broadcasted across all the executors and across all the nodes in which data is stored, and the uh, and it is joined with that bigger table, so the data shuffling reduces, and it reduces the query time by around 50% also, like
Okay.
yeah.
Okay. So what are the type of transformations that you have used in Spark?
Transformations as in with column, and with column and basically sorting with
So
call.
can you tell me what are narrow transformations and what are wide transformations?
Narrow transformation basically deals with like when data is not shuffled while calling the transformations, then it is called as narrow transformation, and when data is shuffled, then it is called as wide transformations. So wide transformation, it can basically be reduced by key or group by key,
Mm-hmm.
that is called as wide transformation, and if you suppose try to map it out or filter it out,
Mm-hmm.
then it is called as narrow transformations.
Okay. So you mentioned about group by key and reduce by key.
Mhm.
Have you used any of these in
No,
your?
I haven't used it. Tell me.
Okay, there's a difference between them. Do you know
Right,
what it is?
right. What happens basically in group by key or reduce by key, in group by key, suppose we have to like we have a data set of log data set, and we have error and wants in it. So since errors and wants are the two distinct keys over here, what happens in group by key, all the data relevant to the error are called out to pulled out into one machine, and all the data relevant to wants are pulled out into another machine, and then they are aggregated in that machine.
Mm-hmm.
But what happens in reduce by key, local aggregation takes place across all the nodes, and then going forward the reduce by key operation takes place. It means the reduce operation takes place.
Mm-hmm.
So it reduces the amount of data shuffled. As
Right.
a result, reduce by key is better than group by key.
Okay. Have you faced out of memory error in Spark?
No, since our data size is small right now,
Okay.
we haven't faced it.
Okay. So if you would have faced, then what are the things that you would do?
If I would have faced it, like one is at cluster level, we would have tried to increase the driver memory.
Mm-hmm.
Uh, and otherwise we would what we would have done, like see one thing is, if the executor size is small, is the execute data means memory allocated to the executor is small, that we will get the out of memory error, that suppose we have allocated if we go with group by key only, what happens, suppose only data which is present in across the two nodes, and it happens that one it's like across the two partitions, and one partition is capable of handling only suppose 400 MB of data, right, or 120 MB of data, and we allocated 4.5 GPU of data, like through group by
Mm-hmm.
key, if it happens. So basically in that situation, we need to try out the salting method. We can try out the
Okay.
salting method, which will help us prevent out the group by means the out of memory error. Other thing
How
is
will salting help out of memory error?
so it will allocate forcefully will try to suppose if there is one, forcefully try to break down into 20 distinct keys, like 1 1 1 2 1 3 1 4
Mm-hmm.
up to 120. So basically the volume of data inside one partition which we try to allocate reduces. As a result, it prevents the out of memory error.
Okay. Do
Mm.
you know about data skewness?
Data skewness, I know, but I haven't faced it still.
Okay. Can you tell me what is data skewness?
Data skewness basically means, suppose we have 200 partitions, and but data is present in only two partitions. So the other 198 partitions are unutilized. So maybe that is data skewness, or like
Yeah. So one partition holding more data than the others, that
yeah,
is
right.
data skewness, right?
Yeah.
Okay. Have you heard about data spilling?
No, I haven't heard about it. Uh,
Okay. Have you heard about cache, persist?
yeah.
What is that?
Cache basically means like cache and persists serve, I mean, serve the same purpose, but in persist, like they are used to store the intermediate results in the memory, and whenever we want in the disk, and whenever you want to retrieve that, like we do not want to rerun the actions from the initials, then we utilize this cache or persist method.
Mm-hmm.
Means by default this cache or persist is in disk only, but in disk we can also mention the other methods, like be it we want to persist it in disk or in memory, or memory and disk, or memory only serializable. So there are multiple methods through which we try to persist it. Most desirable manner is we if you utilize the memory and disk, then it's the best way out, because in disk if we try to store the data, like if we try we if we say means if we try to retrieve the cached data in the disk, then it takes more amount of time, because in disk it's stored in a serialized format. Similarly, if you go with the memory, it takes less time, but it's more the amount of data that's need to be serialized increases, means
Hmm. Okay.
so that's the thing.
So there is another thing that, let's say in the memory is full,
Yeah.
okay, or the disk is full. I mean, with all the cached and persisted data, it's full. So what happens then? It's so full that it's starting spilling out.
So does it go to the office memory? Like I'm not sure
No,
about
so
this.
what happens is there's a concept of LRU, list recently used.
Okay.
So based on that, like the least recently used data that is
Mm.
removed from that, so that it makes space for the new data that can be cached.
Okay. Okay.
Okay.
Got it. Got it.
So, okay. Have you worked on coalesce and repartition?
Yeah, I know about it. I haven't, like, we do not utilize
Okay.
repartition.
When do you use coalesce and when do you use repartition?
Coalesce is utilized whenever we try to specifically try to reduce the number of partitions.
Hmm.
And the partition we can utilize it for both the purposes. But in coalesce, shuffling might happen or might not happen. But in repartition, shuffling occurs for sure. So
Okay.
that's the thing.
So, what do you think is the ideal scenario for using repartition and coalesce?
Repartition should be utilized when specifically we want the data to be distributed in an equal way, like equal
Hmm.
manner across all the partitions. Then we should utilize repartitions. But suppose if our cluster size is not that big, and also the data size is relevant to that cluster size, then we can utilize coalesce. And
Okay.
we want to reduce the number of partitions then only. Yeah.
Okay. So, where does repartition happen, at the driver level or at the executor level?
Repartitions happen at the executor level because it's shuffling occurs.
Mm-hmm. No,
No. Okay.
it happens at the driver level only because it needs a full shuffling, right?
Yeah.
So it shuffles the whole data and then evenly distributes it. So it's
Okay.
most efficient in the scenario when there is data skewness, huge
Okay.
data skewness. Let's say one partition is holding 90% of the data and other partitions are holding remaining 10%. So we obviously need to evenly distribute it, right? So
Yeah.
for that, we will use repartition. That
Okay.
can be a scenario because if we use coalesce, what does it do? It merges the other partitions into bigger partitions. But
Right.
that will not work in this case because one partition is combining everything, right?
Right. Right.
Okay. Um, okay. So, can you tell me the difference between rank, dense rank, and row number?
So should I show it through results, or like how?
Yeah, just you can explain. Yeah.
So basically, what rank happens in rank? What happens? Like rank, dense rank, or row number. All the three are ranking functions within the window functions. But in rank, it tries to assign unique values, but what happens, suppose we have similar tied values, so it will allocate similar rank to them, but it
Hmm.
will skip the
Hmm.
rankings. So suppose if like it will be in this format, so what will rank do, if I try to assign that this is the marks, and uh, we'll rank according to marks, who has scored the highest with rank 1, and going forward like this. So D will be assigned rank 1, B will be assigned rank 2, then S- C will be assigned rank 3, and A will also be assigned rank 3. Now if I add a record E who has a score of suppose 5, so it will just skip the fourth rank and it will assign it 5 rank. Okay,
Hmm.
this is what rank does. Now dense rank, um, basically it will assign similar rank to the tied values, but
Hmm.
it will not skip the ranks.
Hmm.
So this one will be assigned 2, this one will again be assigned 3, this one will be 1, and this one will be 4. 4, yeah,
Hmm.
1 2 3 3 4, yeah. But in row number, what happens, it allocates unique number ranks to all the values. So like it will going forward, if is this is 1, this is 2. Now both of these randomly I'm not sure which one it will allocate, but 3, and let this be 4,
Hmm.
and this one it will allocate as 5.
Unique values.
Yeah, unique values.
Okay, got it. Good. Okay. Can you tell me that what happens internally when we submit a Spark job?
Okay. When we submit a Spark job, what happens is, first of all, the we submit a Spark job to the uh, like resource manager. Okay,
Hmm.
like through the if we do it through the client, like there are two ways when we when we submit a Spark job, it is to the cluster mode. Okay,
Hmm.
so basically what happens, the job is submitted to the resource manager. Now what resource manager does is, the task of resource manager is to only schedule the jobs but not to monitor it. So
Hmm.
it will try to create an application, it will try to assign a container on one of the node managers,
Hmm.
and then through the application manager, within that resource manager, we will try to assign an application master within that node manager. This application master, according to the job, tries to request for the resources from the resource manager. Now the resource manager in turn gives the host name and the machine name, like host name and the like all the relevant details with respect to that machines that have been allocated to that particular job. And then this application master then tries to push the create executors within those allocated machines. And then the job is then it also divides the task into according to the requirement into those multiple node managers, and then the task is done. Yeah,
Got it. Okay.
thank you so much.
Thank you so much. Bye.
Yeah,
Have a nice
bye.
day. All the
Same to
best.
you.
Bye.
Thank you. Bye.